You guys hear that? 30. I've got 30. I'm only missing like 14 people. That's all. Yeah. Okay. Are there any other questions from homework or technical questions? Why is it so loud? Oh, yeah. I got 2 fans going. It's a little bit better. Man, this thing is right up on me. Any questions from homework or... And we were talking earlier, everybody remembers what's happening today, right? Within class. Somebody's saying, yes, I like it. Somebody's like, if we don't say, maybe he forgot. So there's a quiz. So around 6:15, I'm going to stop and get everybody to transition over. I'm going to make it. It's not currently active on Canvas. But if you did log into Canvas very recently, you would have seen a module called Quizzes. And it currently looks empty to you because I haven't released the contents yet. So I'm going to do that in a bit. You're going to pull it up on your screen. You can print it out if you want to. You do not need to print it out. You do the work on a separate sheet of paper. Or you could do it on the quiz itself. If you print it out, you scan it, you send it, and you leave. So that's going to happen later. First thing we're going to do is lecture a little bit. I want to make sure, does anybody... Now that a few more people come in, anybody have any other questions from homework stuff?
Oh, shit, forgot the homework.
Oh, yeah. Wait, I'm here, man. Well, I can't remember 2 things at once. Jeff, are you kidding me?
I actually
the
did.
eyes, number 28 on chapter 2.
28, let me see.
While you're doing that, can I just ask a quick question?
Sure.
In order to go into the next chapters, we have to fulfill the prerequisites for chapter 1, chapter 2 review homework, right?
You got to finish that first module. Yeah, the 0, 1, 2 module. Yeah.
Yeah, okay then. Thank you.
Q. I'm sorry, so you were 28?
20 in chapter 2.
Oh, all right. So, and that's the one 4 minus 3i, right?
Yeah.
So the horizontal axis is the real axis, and the vertical one is the complex, the imaginary axis, right? I mean, that's how that's treated. So the horizontal component will just be the real part, and the vertical component is the imaginary part. That's it.
Got it. Thanks.
Cool. I feel like I was blessing you. The complex blessing of pre-calculus. Anything else, guys, before we jump into some other stuff? Okay. Let me see. Let me get back here. So last time we got through section 3.1. Tonight I want to get 3.2, maybe a little bit into 3.3. We'll see how far I can get before 6:15. Let me share this screen. You can see what looks like kidney beans or something. Sharing an aux cable. I have no idea what they're doing. All right. Horror movies. Function machine. I'm so tired of that. Have you guys heard that functions are like machines? You input something, the machine does something, and it has an output. Ooh.
Yes.
Yes. Okay.
Yes.
That's the most boring shit. I like this though. It's like the kidney bean machine. At least that's something different. And I'm not going to go over. We've already discussed how to represent this on a number line because we're getting into the idea of domain and range. So what is domain? What's the domain of something reference?
The x-axis?
So not just the x-axis, but the
Inputs.
The inputs, exactly. I like it. So not just because your input could be a different variable than x, but because it's not to do with the axis, it's to do with what values from the x-axis can you use? What possible values can you use for x? And then what's the range, of course? That would be
The outputs.
the outputs, all the possible outputs for a given function. So if this is the complete definition of a function right here, can you guys see this? The points here? Can somebody, I'm going to go as if that was a yes. Can somebody tell me what is the domain of this function then? Somebody was there for a second. That's freaky. What's that? Well, I think that might have been a mistake.
2, 3, 4, 5, and 6.
Yeah, 2, 3, 4, 5, 6. Because domain is a collection of all the x values that can or are used. Can be or are used, right? So what about the range?
Is it from 0 to infinity?
No, because which input gives me a value of 7.896? Right? Do you see what I mean? I mean, what are the only outputs allowed by this function as it is defined for us? What are the only outputs allowed by this function right here?
10, 20, 30, 40.
Yep, 10, 20, 30, 40. Do you guys see that? So I can definitely define a function like this, because that's all a function really is a relationship between x and y where every x has only one y. And this exactly matches that. It's not a normal way I consider a function, is it? But who gives a shit? There's a collection of x's that are domain. There's a collection of y's that's range. And no x goes to more than one y. Is everybody cool with that? You guys? Is anybody not cool with that? That might be a better way to ask that. All right. If you logged in and then went back to bed, can you raise your hand? I guess not. Okay. What about, so then this one, of course, that one's not too bad now, right? What's the domain?
-5, 0, 5, 10, 15.
Yep. And then the range is just list all the freaking y's, right? So that's pretty straightforward. So if it's given to me like this, they're basically listing the answers for me, and I'm like, thank you, problem. Thank you very much. So let's do a more interesting one. Well, this is basically not really more interesting. Tell me this. So for example, if I have a problem, if I have a function like this, let me stop sharing for a minute. Whoa, that was freaky. Okay, I don't know what just happened. My Zoom all freaked out. If I have a function like this is related. There's a problem that said, what are the excluded values of x? And there were a few people asked me, all right, Jeff, what the hell does that mean? And that's actually related to domain. If I have a problem, a function like this, what part of the function has a problem for a certain value of x?
The denominator would have a problem if it was -5.
It's a fractional function, so the bottom can't be 0. Therefore, the bottom can't be 0, so x can't be -5. Is that cool? Do you see how I stated the problem in English, and then I wrote that in Mathish? Does that make any sense to you? It's really Lord of the Rings instead of Elvish. It's Mathish. Okay, so watch this. What would you do with this weird shit? How would you find the domain of this? Can you say in English what must happen to make this? And by the way, real quick, before we get too far with this, if I just say find the domain, it's inherently implied that I mean over the real numbers. If I wanted to include complex numbers, I have to actually state find the domain over the complex numbers. So when I say find the domain, I inherently mean over the real numbers.
The square root can't be, it can't be like the square root of a negative number, so x
So the
can't
inside has to be what?
positive.
Let's say the thing.
Positive.
Inside positive. Can we make that a little bit more mathish? The inside
Even number?
Be,
A real number?
no. I want the result to be real. But the inside, I agree, must be positive, or what? What number that's not positive can the inside still be?
0.
0. So it must be positive or 0. Can you say that in a more mathish way?
Must be greater than or equal to -7.
No, you went too far from this.
Must
The
be a whole
inside
number?
has to be greater than, it has to be at least 0, right? Do you understand?
Yeah.
Now
Okay.
you write what you just said. I'm trying to give you a general way to find domain for any function now and in the future that you learn. And we will learn a lot of new functions that you've never seen before this semester. Or maybe some of you have. Yeah, greater than or equal to 0. I love it, Josh. So then the function itself, independent of what's inside, this function requires this to be true, to be real. And then you rewrite this in in mathish. Inside, x plus 7, at least 0, greater than or equal to 0. And then you solve it. You can do it, Jeff. There you go, buddy. And then you can write that in interval notation. And you can put that on a number line. And all kinds of weird shit. Become a thing. Become a thing. There you go. Maybe? No?
Yes.
Okay. You can just humor me. All right. I really want you guys to get the idea, because when we hit other functions, if you could just say in English what the problem is or what must happen. If you just say it in English, then write what you just said in mathish and then solve it. That's how you do almost any domain. See how I covered my ass there? Almost any. Oh. All right. What was I doing? Wait. So coming back to the book here. I've got to do something about, oh, I have no idea. By the way, well, you should be getting an official announcement from the school that we will almost definitely be online in the spring also. Sorry. Barring some amazing miracle. We'll find out. Hopefully, I'm still hopeful, but right now we're planning on being online. All right, what else I want to show you? Oh yeah. So here, take a minute and try this one. Shh, why are these always so tiny? Why are you so tiny? Come here. My God. There we go. Not you. I don't want you. What's wrong with me? Shut up. This one. Man, I had to zoom in a lot. Teaching is so different now. I got a sea of black boxes with names. I have no idea. I can't gauge anybody anymore. You guys okay out there? Everybody understand what you're doing right now?
Yeah.
Okay. Whew. For a minute there, I'm like, did my Wi-Fi give up? And I just don't even know. I've been talking to myself for like 10 minutes. So what's the first step on this?
Solve for x.
Well, that's not the first step. You haven't got anything set up yet to solve.
You multiply 2x minus 1.
What do you mean multiply? What's happening?
You.
So find the domain. So what can't happen in this function?
Denominator
That the
can't
denominator
equal
can't
0.
be, yeah.
Yes, denominator. Oh my God, that's what happened, Jeff. I have it set to spray can. Okay, denominator. What the flip? I'm just going to use the letter D. Denominator can't be 0. So 2x minus 1 can't be 0. And then you just solve that. Not a big deal, right? Add 1 divided by 2, you get x can't be.
1/2.
There you go. Cool. That's the only number that makes the bottom 0. Easy peasy, lemon squeezy, no problem. Let me see. Does anyone, well, I'm going to ask this, and then it doesn't really matter because I'm going to do it anyway. Does anyone want a more challenging one?
Sure.
Yeah.
Sure.
All right, I like it. That's the answer I wanted. If everybody would have said no, I'd have said, it doesn't matter. I'm going to do it anyway. You should know. So look at this. I don't know. This is crazy. Rawr. All right. So what's the domain? Yeah. What you got, Jeff? Sure. This one isn't that much more of a challenge, but I probably just made some of you guys feel bad. I don't know, sorry. Somebody's got it down. I'm sorry. I disappointed somebody. Somebody's giving me a thumbs down. Oh, somebody didn't want it. Too bad. You got it. You already know how to do this. You already know. So if that wasn't there, if the square root wasn't there, it would be a problem like we just did, right?
Yeah.
You would say 2 minus x can't be 0, right?
Yes.
Okay. But what else has to happen now that I put the square root on? Not only can it not equal 0, but this whole thing has to be
Positive.
positive, which means the bottom has to be positive.
Positive.
The score is already positive. So in which case, so if it was only a square root, you would say this. If there was no square root, only a denominator, you would say not equal to. So what are you going to do? What are you going to leave out of this?
Would it just be 2 minus x is greater than 0?
Beautiful. So all you do, the square root makes it have to be at least 0, and the fact that it's in the denominator says it can't be 0. So you throw that possibility out also. Do you see that?
Yep.
Yeah.
Sweet. That's not that bad, right? So then x is less than 2. Yay. You need to do whatever, you graph it and all that kind of shit. Whatever they want you to do. I like it. All right. Let's see what other weird stuff the book does. All right, book. Do. What are you doing? Holy shit. Okay, all right. So now we get a little more interesting here. Let me find a good example of this. Sure. All right. So this is another example of the problem we were doing earlier about domain and range, but now it's visual. Let me zoom in a little bit. Don't freak out on me. Okay, thank you. All right, take a minute. Don't say anything. Figure out the domain and range of this function. Write it in interval notation, both of them.
The domain is the x, correct?
The domain is all the x values that can and are used, and the range is all the y values that can and do come out of the function that are outputs. Yes.
Got it.
I like it. So when I teach this to people for the first time, which I am not, but I just want to show you because this should be old news. I used to say, I have a little dude. Here's my little dude. Right? Don't make fun of him. He's got problems. And if he walks along the x-axis, when's the first time, if he's looking up and down, when's the first time that he sees the function? Almost at what? Where's the first place he sees the function as he's walking?
-3.
Yeah, -3. But do I include -3?
No.
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 Open circle. I love it. And of course, he walks, he walks, he walks, he walks. He doesn't lose sight of it until, of course, 1, right? Right after 1, he loses sight of it. Poor little dude. So it's up to 1 inclusive. That's the domain. So who's got the range? Do the same thing, except now he's climbing up the y-axis. What's the first place he sees it, and what's the last place he sees it? What's the range going to be?
So -6, 0.
No. Careful. Does he see it at -6, looking left and right?
Oh,
Is -6 an output? No. What's the first output?
-4.
-4 is the first output. It happens in a few places, a couple. So from -4, it's a bracket because it's a filled-in circle there, up to, where's the last place he sees it?
0.
0.
Here. Is that a bracket or a parenthesis?
Parenthesis?
It could be a bracket, right?
Well, I got some dissension. Let's see. In the chat, somebody sent me a private chat, and I will tell you, you are wrong. I'm sorry. Good. Thanks for playing. Why is it a bracket for damn sure? Sure, there's an open circle there, right? But doesn't it attain 0 here?
Yep.
So 0 is included in the realm of all possible outputs because it does attain 0. Do you guys see that?
Say that one more time, please.
Sure. Does it have an output of 0 somewhere?
Yes.
Therefore, 0 should be in the range. Does it hit 0 here?
Yeah.
No. Does it hit 0 here? Yeah.
Wait, so parentheses, you put if it doesn't hit something, and then the bracket
Remember-
if it does hit something?
Yeah, real quick. Remember in the old days when you would do something, you would have like an open circle and a closed circle. Open circle meant don't include, right? Right?
Yeah.
Right.
Okay, thank you. So what's half of an open circle look like? Parenthesis. And then what's the word include? What letter does the word include start with? I. Well, what happens if you erase that? You get a bracket. That's how that's how I first remember it. I don't need that shit anymore, but whatever works. Is that cool? You guys all right? So the bracket means it is included in that set. And since 0 is an output, I have to include it in the set. How many times is -1 an output?
3 times.
3 times. There,
3 times.
there, and there. Is it going to show up in here 3 times? No, it just shows up once because it's an output. It doesn't matter how often it is, right? Let me see. How do I do that from here? Can everybody mute yourselves? Somebody's got something happening. I guess not. Okay. There was one more thing I want to ask. Oh, yeah. F of what is -4?
F of 0.
No, f of 0 is 0.
F of -2 and F of 1.
Ah, f of -2 is -4, and f of 1 is -4. Do you guys see that?
Oh, because it's where it meets, right? -4.
Yeah, it's where the point is. So why did somebody put a point there? Because it goes through the point -2, -4. Therefore, f of -2 must be -4. So if somebody gives you a graph, they've already done all the work. So questions like this should be easy. I just have to look at the work they did. Is that?
Would
you guys?
Would you write the 1?
Yeah, and then the other one is f. So if the question was, what are all the values of x where the output's -4, it would be -2 and 1. And hopefully you would write it less like a 4-year-old kid, but oh well. That's all I can do with this. All right. Man, I'm surprised you guys could have drawn all over this, but you have a lot of restraint. You don't even know how to do that maybe, but you can't do it anymore. Anyway, all right. All right, enough of that one. I'm going to clear that. Is that all right? Any other questions on all that stuff we just did? Hopefully most of that is review. I'm going to clear all my drawings. Bye, little dude. All right. All right, let me see. I don't think there was anything else too interesting in here. They go over all the shapes. I think we've gone over these shapes before, if I'm not mistaken. There's a cubish one. I called it a giraffe graph that my friend calls it. And it's just so morbid. The giraffe is about to keel over from somebody cutting his leg off. This is the most basic hyperbola. This is the one that I was talking about with the asymptote in the middle. This is your radical. This is like an even root, and this is an odd root. It allows for negatives. Go. Oh, real quick. What's the domain? Oh, shit. I don't want to do that. Get out of there. All right. What is the domain of this function before I forget? Holy, would you, what? What just happened? Okay. I don't know why this thing. All right, let me just do this. Let's see if I can deal with that. Oh, yeah, let's try. What do you got, Jeff? I don't know. This should take you approximately 0.3 seconds to do.
Is it all real numbers?
Yes, why? 2 reasons. Is there any problem with the inside? What kind of thing is the inside? What kind of function?
Polynomial.
Polynomial. And polynomials are given that name. We gave them their own name because they're a class of functions that can handle every input. And what kind of root am I using?
A cubic root.
Cube.
In fact, an odd root. And odd roots can handle positive and negative inputs. So no part of this function has an issue. So there's nothing that would take away from the domain being all real numbers. And you can call that this. You can do it, Jeff. There's a negative there. Pretend like there is. You can call that this. Ooh, yeah, all real numbers. It's got an extra spine to it, right? Let me make sure you guys can see that negative. Aw. Yes? Okay, all right. Just want to make sure before I went too far that cube roots have no issues themselves. It all depends on what's inside of them. Okay, let me see. Let me look real quick. I don't think there was anything else I wanted to talk about. Oh, okay, here's the, okay. I didn't realize it was in this section. So for some reason, all right, for some reason, this gives students a lot of trouble. Has anyone heard of something called piecewise defined functions? One person thought they did. It was interesting. I had a yes that existed for about, okay, so let me show you. Sounds familiar. I like it. Okay. And I know I've already kind of poisoned the well by saying a lot of students have trouble with it, but I don't understand why necessarily. So let me say, what if I asked you graph this, but only for x greater than or equal to 1? Can you guys do that for me real quick? This is not a piecewise function yet, but just do this. I'll graph this, but only for x greater than or equal to 1. Is that a difficult thing to do?
No.
I like that. So do it. And you can make a table of values if you want to. You shouldn't really need to. You can do it as you go. What is happening? I don't know. Something's happening in my backyard. Let's do 2, 4, 6, 8. All right, so for x greater than or equal to 1, so when I put a 1 in, I would get a 2 out. When I put a 2 in, I get a 5 out. When I put a 3 in, get up there, I get a 10 out. How's everybody doing?
Good.
Good? Okay. What if I said, Now, on this same graph, what, Jeff? I don't know, Jeff. Sure, square root. Oh, shit. All right, you're gone. I got more colors coming tomorrow, but not today. Square root of 1 minus x on this same graph for x less than 1. I don't know. This one might freak a few people out, but you got to know what the basic look of a square root is. I don't know if some of you guys realize when the x is negative like this, it's going to reflect it. But even if you don't know any of that, now watch what I'm about to do. I could have made an XY table up here. Now I'm going to make myself a little XY table here. Am I allowed to use 1 for this?
No.
But I'm going to put it in anyway. But I'm going to do this. This is my own personal notation. I'm going to put 1 in, but I'm going to put parentheses like, oh, I'm not supposed to do this. But can anyone figure out why?
Because 0 is undefined under a square root.
It's not undefined. No. What's the square root of 0?
0.
0.
Oh, 0.
I don't know if what you mean is this. No, now, you should have let me say this to pretend like this is what you meant. I'm not allowed to use 1. But if I don't do this, I don't know where to put the what.
The open circle.
Open circle, kick ass. So you have to do this to know where to put the open circle. So I'm going to put an open circle at 0. What do I get when I put a 0 in? I'm allowed to use 0. I get remarkably enough, I get 1, right? And then if I put negative 3 in, no, you can do better than that, Jeff. Can you, Jeff? Can you do better than that, Jeff? Yes, if you put a negative, yeah, sure, negative 3 is fine. You get 2, right? 1, 2, 3. So now it looks like that. Let me stop for a minute. Do you understand how I have 2 functions? I did them one at a time, and I didn't use all the values of x. I only used the values that they told me I could. Is everybody with me on that? Was that amazing? Here is what it would look like as a piecewise function. Do you see why we use that word? It's a function that's in pieces, and we're wise. We try to make it sound like Pennywise, so it sounded really scary, right? Or stupid, depending on your opinion. So here's what it will look like as a piecewise function. I have no room anywhere. Jeff. You have to learn how to, all right, let me put it over here. You guys still see that? I have no idea. Yes. So this is what it would look like. Let me just take that away. It puts those 2 things we did, it just puts them together. F of x is this if I have something at least 1 in input, and it's this if I have something less than 1 as an input. That's what a piecewise function looks like. So how do I graph a piecewise function? I take this and I graph it only using those values, and I take this and I graph it on top of that, only using these values. And whoever's got the one that can't equal, I still do it so I know where to put the open circle. How do you guys feel about that? If you've never seen that before, does that make okay sense? Or does it make no sense?
Makes sense. My question would just be like, why would you do that? Like, what would be an application for that?
This is beautiful. So, would you agree that I have an equation for a rocket after I shoot it off, right? In fact, that's sort of like how we program the rocket. Let's pretend like this is a missile that has its own trajectory controls, and I can program it with a certain trajectory I want it to take, right? Is that cool?
Sure.
And then let's say that something else comes and hits it, or it hits something like a little meteor, such a crazy thing. It comes in and hits it. Does my function that describes the trajectory doesn't change.
No.
It doesn't change. So let's say this is a decent sized meteor. It's going to hit it and it's going to change, isn't it?
Yeah.
All right, there you go. So at that moment, so this could be 1 second after we've launched it, something happens. So it won't be drastic like this. This would be kind of crazy. This would be instantaneous what do you call it? Instantaneous transmission, right? If there's any Dragon Ball Z people out there. So this might not be, but I could have a function that looks like this. You launch it, it hits something here, and then the trajectory becomes this. So it was on this trajectory, now it's on a different one. So that is one of the many examples of what use this has as a piecewise function, because you want to talk about the complete journey. But to do that, you have to use possibly multiple functions on the way based on different things. Either we programmed it to change course or something happened that made it change course. Does that make sense?
Yeah, that makes sense.
A little bit of sense. And of course, there's more than just that, right? Okay. Where are we at time-wise? Okay, pretty soon. I did want to get a little bit into the next section. So here, let me give you another example of these. We might not get in the next section. I'll be okay with that. So here's one that's got 3 pieces to it, right? So what I would highly recommend when you have to do a problem like this middle problem is easy. Is that okay to say? Is anyone offended by me saying that? It's like, don't make no assumptions about me. But that should be easy now. Of constant function 3. Okay, that's easy. I would highly recommend, especially if you're not very comfortable with this, I would make an XY table for x squared. Like I made an XY table for that 1 up there. And I have to use less than or equal to 1, so I can put a 1 in there, I can put a 0 in there, I can put a -1 in there. Is that cool? I'm going to pretend like that's cool. And then for this one, this is really just a straight line, but I have to start at 2, right? 2, 2. But I'm going to put these in parentheses, so that's going to tell me exactly where there should be an open circle. Let me stop for a minute. Are you guys at all with me? So it's...
I am following.
You're following, okay. Okay. So that's really all there is to it. So like if we do this, if you can bear with me with this horrible writing, 1 squared is 1, 0 squared is 0, -1 squared is 1, and we know what the shape of a parabola is, so I don't really have to do a lot with that. I just know it has to stop at 1. So what do I have so far? I've got, let's see, -1 goes to 1. And then here is going to be a closed circle because it's allowed to equal. Please become a closed circle. And then I've got, oh God, pretend like that's a parabola. Pretend like it's got a curve. Then you take this guy. Well, first off, between 1 and 2, the value is 3 constantly. So it's just going to be, starting here, it's going to be, is it allowed to be 3 at 1? That's such a weird question, but you guys understand what I'm saying? Is it allowed to be 3 at 1? No, because it's not allowed to equal 1 for this middle. I can't have an input of 1. So here it's got to have an open circle. If that was a closed circle, why would I know I'm wrong immediately if I put a closed circle right there?
Because it can't equal. No.
What kind of thing am I saying this is? I'm saying this is a function, right? What test can it not fail?
The horizontal line test.
Vertical line test.
Vertically.
Yeah. Horizontals for inverse functions. So if I had this closed in, I would know I'm wrong because the vertical line test would be failed right there. So you have some checks and balances here. And then it's 3 straight across until here, and that's where it's allowed to be. So that would be a closed, become a closed, just do it. Okay. And then starting here at 2, 2, it's got an open circle, right? Because at 2, it wants to be 2, but it can't. It's not allowed to be because it's not equal to. And then at 3, it's 3, and then it just goes from there. So at 3, it's 3, and then it's a straight line. So this is a, oh my God, just pretend like that's good. So here's a parabola down here, and then this constant function takes over, and then this linear function takes over. So that's, if you just make tables of values, put them in, this is my own creation, but the little parentheses reminds me, oh, an open circle goes there. I don't know, is that, you have to try it out yourself to really see if you can do it. For some reason, people just cannot get it into their head to just stop thinking parabolically at 1. It just stops. And then something else takes over. They want to have it overlapping with everything. No, just stop. Just stop it right there at 1. It just stops being a parabola. Okay. I'm going to pretend like that's okay because nobody's saying anything to me. All right. Thank you, Amber. All right. Let me see. I'm going to clear that. So hopefully that's all you wanted from that insane football play here. I don't know what the hell it is. It's gone. Okay. So let me see. I think that was all. Yeah. Good. You're good. So one last thing, and then I'll get the, yeah, good. I got like just a few minutes. Sorry, I'm making you sick here. Am I still sharing? Yes. One last thing I wanted, just a little preview of 3.3. So for example, here is the cost of gasoline. I wonder what state this is. Oh, well, from 2005 to 2012. So what would your first instinct be if I said, what's the average increase in gas from 2006 to 2008? What's the average rate of change of gas price between 2006 and 2008? What am I really asking you to find?
The slope.
The slope. So the function itself is not linear. If you look at it, it's up and down, up and down. You guys see that?
Yeah.
You know, like gas prices do, obviously. But if I just want average rate of change, so if I have a function, it can look like whatever the shit. But if I want an average rate of change between 2 points, I do as the crow flies between them. So another name for average rate of change is slope between 2 points. So some of the problems are going to look exactly like this. They're going to give you a bunch of data, and they're going to say, okay, from 2006 to 2009, what was the average rate of change? And you just do the slope formula. You do y2 minus y1 over x2 minus x1. Kabam. And in fact, a little bit later here, right there, let me see if they got it bigger. I think they, yeah. I don't know if you guys remember, but one of these nights last week, I showed you this formula for the f of x plus h thing. It was that's just y2 minus y1 over x2 minus x1, same thing. And then the absolute last thing I want to say tonight, where was it? Oh, yeah. Oh, come on. Well, anyway, all right. I got like no time. They're going to give you a function, and they're going to ask you, where is it increasing? Can somebody tell me? They're telling you. You can see it. But can somebody tell me interval notation? Can you type it in the chat? On what interval is this function decreasing? And a really good question would be, how do I answer that? What do I use? So when I want to talk about where something's happening on a function, I use x values. So where is this thing decreasing? Careful, Doug. No? Yes. Who is it? Deja. And why? Now Luke, I'm not picking on you because Jackie did it too, so no big deal. What's kind of wrong about what Luke and Jackie wrote? I'm sorry, Luke and Jackie. I'm sorry. You just happen to be a really good example. Everybody would have done that. Don't freak out. What's kind of wrong about that? What is it doing right here at that point? Is it going up or down right at that point?
Still going up.
No.
It's not
about to go down.
No, it's not going up. It's just flat.
It just stopped going up. It's about to go down. So what is it doing right at that point? Nothing. That's sort of like when you throw a pen up in the air and it's just about to start falling and it hasn't fallen yet. It's not going up or down. So where is it decreasing? It should be a parenthesis because it's not going up or down at the turning points. That's a very small detail, I know, and I'm not that big on it, but just to be careful. Yeah, exactly, Deja. The slope is 0 here, and the slope is 0 here. Slope is positive, 0 negative, 0 positive. Okay, and on that positive note, I'm going to stop lecture. And here's any questions on that before I let that go?
Would it be the same thing with 2 because it starts increasing again?
Yeah, so if I asked you what intervals is it increasing on, you'd have to give me 2 separate intervals, right? One stopping at -2, parenthesis, and the other one starting at 2, parenthesis.
Oh, okay.
Cool, I like it. All right, so here's how this is gonna work. I'm gonna make this active on Canvas, so hopefully you are able to access Canvas right now. So get into Canvas right now. Let me make this active. Okay, now it's active. Let me make sure if Past Jeff did all this right. Oh, good job, Past Jeff. So if you go into Canvas right now, you should see a module. In fact, let me share my screen. And let me become a student. When it's purple, I'm a student. Okay, I'm a student now. Oh, I don't like this. I already did my time. You should see a module right here in between Chapter 3 homework and the Unit 0 and 2 stuff with Quiz 1 on Chapter 1 and 2. Here's a little preview, but you can also click this if you want to download it. I'm not going to do that. Go. Just stop. I don't want to do it. Or you can just work on it straight from here. Is everybody with me? Could everybody turn on your cameras now? Oh, this is going to do some neat shit to my bandwidth. Hopefully everybody's, nobody's transitioned to jammies already. All right. So I need you to, you don't have to print this out, but you can if you want to. Go ahead and start working on this. Am I still sharing? No. Go ahead and start working on this. And when you get done, you're going to scan it and turn it in. I've given you until 6:55 p.m., right? So that's some built-in time for any technical issues. And they shouldn't take you that long, is my hope. And I probably should, to make it easy on myself, let me see. How am I feeling right now? Sure. Oh, my niece and my friend's kids are big into this game now, so they were really excited when they were FaceTiming me and I had Minecraft background. Anyway, just so you don't get any hints from, you know, the board. Hell yeah. So again, Doug, you're okay. For this first one, I'm going to have to be a little bit trusting, but, and you can, please, you do not have to print it out. You could do it on another sheet of paper. Either way, I want you to write it out. You can print it out and do it on there if you want to. You don't have to. And when you're done, scan it and turn it in right where you got it from. Please tell me I did that right. Oh, shit. Yes, thank God. Oh, God. All right. Please let me know if you're having any technical difficulties. Please let me know. And real quick, as you get started, I do know that photomath exists, for one thing. I like to look at people's faces when I say that. Some people go, what's photomath? And other people go, oh. And I know what shit looks like that comes out of it, so let's not do that. Let's not use that shit. You'll get a 0, and if you do it again, you'll just fail the course. So it's a really stupid thing to do. With that said, good luck. Do it. Let me see here. Julianne, are you out there? Man, a lot of you guys logged in with no. Julian Reyes. Is Jose's iPhone out there? There you are. All right. That's better. Oh, I'm sorry, dude. Go ahead. You got a phone. You can turn the camera off. Go ahead and get Canvas. Brian, you shouldn't disconnect from Zoom. It should just turn your camera off if you have it on. So turn your, it shouldn't disconnect you though.